Okay, so we're going to talk about hydrates. So before we begin doing an actual hydrate problem, we're first going to go over two terms that are going to be important to know because it's important to know what you are dealing with, what they actually mean. So what is a hydrate? A hydrate is an ionic compound with loosely attached H2Os within the repeating structure. And the other term that we're going to be talking about is an anhydrate, which is the hydrate without the H2Os. This is the first problem. A hydrate is determined to be 45.43% water and 54.57% CoCl2. Find the chemical formula and name for this hydrate. Okay, so this question has two important pieces of information that we're going to need to use. The first is that the percent of water is 45.43%. So that's important. And that's the water. And then you have 54.57% of CoCl2. And then it's asking you two things. One is to find the chemical formula, and the other is to find the name for this hydrate. So first, we're going to calculate for the CoCl2, which are the cobalt chlorides. So we're kind of going to start filling this chart in from top to bottom. So on the upper corner here, we're going to take the 54.57 grams of CoCl2, which was the number from the question. And then next to it, we're going to do the conversion formula to AMUs, which is 6.02 times 10 to the 23rd AMU. Then next to it, we're going to do 1 CoCl2. And then under the conversion formula, we're going to have 1 gram of CoCl2, sorry. Okay, and then next to that, you're going to do the mass of 1 CoCl2. So how to get that is you have to have a periodic table in front of you, and you're going to look at the mass, which is the little number underneath the element of CO, and then you're going to add that to Cl, but there's 2 Cl, so make sure you multiply chlorine's mass by 2, so times 2, and then add the mass of cobalt to that. And whatever that number is, which I think you should get around 129, your numbers might be slightly different if you rounded differently, but you should get 129, and that is AMU. So now you should see that this kind of lines up. Here you have CoCl2, here you have CoCl2, AMU, AMU, CoCl2. So those cross out since they're crossing each other. So everything on the top you're going to multiply, and everything on the bottom you're going to divide by. So the CoCl2's cross out, AMU's cross out. So then you're left with, to put in your calculator, 54.57 times 6.02 times 10 to the 23rd, and then times 1, which you don't have to do that. And then whatever that number is, you're going to divide by 129, because that number's on the bottom. And you should get around 2.552 times 10 to the 23rd AMU CO Cl2. So it's very important to make sure you label all the units. See, you're doing grams of CoCl2, AMU, because to make sure it's important to know what you're talking about. So now, this is your answer for that. But now we have to do the same thing with the H2Os. Okay, so now we're going to use the same method to deal with the H2Os. So on the top here, remember, we're going to do the number that was in the question it was asking, which was 45.43%. And that's grams, but now this time it's H2O. And then under here, we're going to do 1 gram of H2O because those are going to cancel out. Up top, we're going to do the conversion formula for AMU. Next to it, we're going to have 1 H2O. And below it, we're going to have the mass of 1 H2O, which, if you add that up, 2 hydrogens and an oxygen, you should get 18 AMU. So you'll plug this into your calculator. Across 45.3 grams times 6.02 times 10 to the 23rd, and then divide that number by 18. And you should get around 1.515 times 10 to the 24th AMU, and then don't forget H2O. And then this is your other answer, and you're going to do something with those answers in just a sec. Also, I forgot to say, don't forget that these cancel out because they're across from each other. So that's how you get to your answer. Okay, so now we're going to use those two numbers that we just solved for, and we're going to plug them into this, which is just dividing. And you're going to take, so on top is going to be the H2O number. So that number is 1.515 times 10 to the 24th AMU of H2O. And you're going to divide that by the number of CoCl2, of cobalt chloride. So that number was 2.552 times 10 to the 23rd AMU of CoCl2. Okay. And then, simple, you just plug that into your calculator, the top number divided by the bottom number, and you should get around 5.93, but we're going to aim for whole numbers when dealing with hydrates, so you can round that. So approximately 6. All right. Okay, so the last two steps are finding the chemical formula and the name for the hydrate. So to write the chemical formula, you're going to write the anhydrate, which was the CoCl2. Whoops. And then you're going to write this like times. And then the number that you got for our answer, which was 6, because that was the number of H2Os. And then you're going to write H2O. And there you have your chemical formula. And the last part they're asking for is the name. So to find the name, well, you're naming the formula. So you have CoCl2, which is cobalt chloride. So you can write that. And then, to name the rest, the 6 H2Os, there's a numbering system 1 through 10, which is mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So for 6, the name is hexa. So you're going to write hexahydrate because the H2O is the hydrate. And that is your answer for the name. So this is the end of the video for hydrates, and I hope this helps. Good luck!